Okay, just let me remind you what we discussed in now. We started this semester with renewable and sustainable energy. We went through the revision for the global situation, energy global situation, and then after that we discussed the different type of non-renewable and renewable energy, so we can compare between them. We highlighted the advantages, disadvantages. After that, in one lecture, in one session, we discussed the sustainability. Then we started with the different type of different sources of renewable energy. We started from solar energy. We went from in the journey from the sun to the atom, through the space to the atmosphere, in the sky to the collector. We discussed the insulation, or let me say power density we collect through our collector. We have formula, angles, parameters we use to calculate this energy, and after that we revise different collectors, okay, different methods to collect solar energy. The first collector discussed in more details is the photovoltaic or solar cell. We discussed them. We went through the solar cell from history to the atom level, then to the panel, to the, let me say, cell, then module, panel array configuration, systems, applications, technical and economical aspects. We will discuss all these things. After that, solar thermal, we discussed them. We discussed solar thermal, different type of solar thermal, the concentrated one and the, let me say, solar water collector, air collector. And hybrid system has been discussed also, which utilize photovoltaic and solar thermal collector in one, let me say, package. When we completed the solar energy part, we moved to the wind energy part. Also, we discuss wind energy. We design wind energy. We look to technical and economical aspect. Today, I will start with another topic, which is hydro power. And simply, sorry. Okay. Simply, hydropower, the hydropower is a natural phenomenon. We are talking about the pressure of water. When we put the pressure on something, force, we can capture this force and utilize it one way or another, as I will explain. Let me start from this figure here. As you can see, we have most of our planet covered by water, more than 70%. So it is already there, natural solar collector installed and paid for. It's there, it's free. If we know how to utilize its energy, this will be great, as we are going to see how many methods we can utilize energy from water, but one of them is the hydro. And hydro related to the water pressure. And water have a cycle. Cycle started from here, from the ocean, from the sea. Because of solar energy, it gets heated, it evaporated, it go there as clouds, and then it's fell as snow or precipitation or what, rain. And then we have water to produce rivers, to produce lake, and so on. When we, let me say, save this water behind dam, okay, we have a pressure now. If we open the gates, water will come and put the pressure on the blades of the turbine, rotate the turbine, generator will generate electricity. Very simple and clear and straightforward. So again, it seems to be hydro is a reflection of solar. As I mentioned always, solar is the main, everything or almost either direct or indirect reflection of solar. Now here, as you can see here, this is our dam, okay? This is water saved in this dam, behind this dam, and there is heat. Pressure will be put here. If we make a channel here, okay, tunnel here, then turbine here, water will go here. When we open the gate, water will go here and rotate the turbo generator over there, and we generate electricity. It has been used long time back. As you can see here, this is water wheel, water flow, it's rotate, we have shaft, gearbox, generator, generate electricity and use it. In the past, it's used for grinding, mainly for grinding. But let's have a look at these statistics. It's old statistics, 20 years back, talking about 2001. It's published by International Energy Agency. And you can see here the share of power sources. See, hydro. Hydro have interesting share. When you say 7%, it's really huge. We're talking about around 777 gigawatt, as I will show later. So hydro is really interesting source of energy. We can utilize it. We can use it in many applications. This is from history. In the past, they use it, as you can see here, to grind either corn, wheat. You see here, we put it here, we grind it. We need mechanical energy to rotate it. We rotate it by this blade. Okay, the blades is rotated by the pressure we put through the hydro on these blades. Or another way, this is water wheel. It's rotate, produce mechanical energy. Here we have gearbox, shaft. We grind here the corn as example, and many other ways we use to generate electricity. They use this way. I mean, as you can see here, sorry, in this way, they use the water here, put the pressure, so it's rotate. It's used mainly to drive, let me say, ships in rivers. Still, with the statistics, if we look to this is statistics also from EII, it's with the projection up to 2050, 1990 up to 2050. Okay, we can see we are here 21, right? We can see the expectation at 2050. Here, these parts equal to these parts, 50%, 50%. Here, 50% is renewable. See, the hydro have almost 1/3 of the energy used to generate electricity. This is what we are talking about 2050. Okay. But also hydro have advantages and disadvantages. I will go through them. Now, first of all, we don't expect hydro available everywhere. Okay. In some places, they have shortage in water from the beginning. And some places they build dam and they depend on rain. They have seasons, rain seasons, and if a dry season came, this is a problem. Some of them, they have, let me say, ability to make a reservoir, or a dam, but what they do, they are close to the ocean. They try to pump water from the ocean to the reservoir, and sometime through the day, using some technology, one technology or another. Okay. But at the end, they use the pressure of this water to rotate turbo generator. More, I'm trying to focus mainly here on the disadvantages. When we build a dam for hydro power plant, we change the construction of the land forever. Okay, the infrastructure, it takes a long time, talking about maybe 4, 5, 6 years, and we change everything there. So if people or animals or agriculture there, this will be affected by these constructions. People habits could change because of this. Okay, animals could leave the place or affected by this, and so on. Let me say the agriculture side. But let's look to the bright side, the advantages. We are talking about no waste system, let me say, system or energy system, because we are not burning fuel now. There is no ash, there is no CO2, nothing. And also comparing with other, we can say it's really low CO2 emission, let me say, technology. It's huge. See the installed capacity, 777. It's a simple number to remember. 777 gigawatt electricity generated. This is old, now talking about 2006. Today it's increased. People everywhere, because they want to have a policy for water, for saving water, saving and utilizing water, they make a dam. Okay, because I mean, you know that I remember, let me say, the from reading the history that last century, at the end of last century, they've been talking that shortage in water will lead to many war here and here between countries. Okay, for that people are scaring from having shortage in water. So what they did, they start making dam, artificial lake, saving water, making dam. So since we have a dam and we have a water, we can use it at the same time to generate electricity. Now these are all data, still all data. Okay, world annual hydro output. These are the years, talking from 1965 into 2005. This is annual output, the capacity. Okay, you see we have almost straight line and straight line growth, sharp, which means that this technology get interest by countries, by government, by organization, by communities. And here also I try to show you some information about people, let me say the producers, countries, the producers, or installed capacity or countries invest in hydro energy. Example, Canada, Brazil, United States, Russia, Norway, and so on. Now let's see how much energy, okay, they produce. Let me see first the unit. Oh, terawatt hour. We are talking not about mega or giga, terawatt hour. See, 338, 306, 306. So this means that they depend on it. They take it serious. It's not for village. It's not for small or simple, let me isolated community. They talk about large cities. And for capacity, okay, see the United States of America, they install 94 gigawatt. It's huge. You need to compare always that 1 gigawatt is a nuclear power plant. So 94, it means 94 nuclear power plant, equivalent to 94 nuclear power plant. Many countries, as we see here, Canada, we are talking about large numbers, okay? This is the dam. Don't expect that these infrastructures are easy to build. It's really huge. The investment is huge, time needed, and materials, infrastructure is really difficult to be done here. See here from close photo, okay? Because the pressure will be put here on the dam. See the infrastructure near the dam. All these are infrastructure. You see here, it changed everything. It changed the location. Now let's come to talk about how much the power energy can be produced by by hydro technology. Two things need to be considered here. One is the head, and one is the flow, water flow. These two elements are the main elements specify how much power to be generated, how much energy to be produced. Now first let me define head. Head, imagine this is the surface of water, and this is here we open the gate. So head is the distance here. It's important. We increase the head, we increase the power and energy. They classify them based on heads into, as you can see here, high head, medium head, low head. High head greater than 800 feet. Between 100 to 800 is medium head, and lower than 100 is the low head. Also, based on their rating, they classify the power plants, hydropower plants, into large hydro, talking about more than 100 mega. medium between 15 to 100 mega, small between 1 to 15 mega, okay, mini 100 kilo to 1 mega, micro 5 kilo to 100 kilo, pico less than 5 kilo. Just a minute. Why this classification? What they want to say? They want to say whenever you have opportunity to have water and you can save it to generate electricity, go ahead, even if it is very small or it is very high or large. As example here in large scale, 100, more than 100. Less than 5 kilo, talking about house. Usually houses consume between, in general, between 5 kilo to 10 kilo. And also, if you have between 5 kilo to 100 kilo, they can produce for small community, for rural area, for villages. The same thing for less than, little bit more than 100 kilo. So there is opportunity, go ahead. Now, these are the heads, as you can see here, low head. The head is low. While this is the turbo generator. This is the dam, the barrage. And here you can see these are the turbo generator, and water will come from here. The head is medium, and this is the high head. You see? Since we are using turbine to generate the mechanical energy, taking the pressure of the hydro, okay, we expect that we have blades. See different blades. I talk about this actually in wind because it's the same idea here. Now designing different blades, optimize them, it's related to its properties, its characteristics, its pressure, its movement, the dam itself, all of these. For that we see different design. Now, before I talk about efficiency for hydropower, just let me remind you the efficiency for solar and for wind. To compare. Have a look. When we talk about solar, we say that less than 10% is the efficiency of amorphous silicon technology. This is what's available in the market. Between 15 to 20, less than 15 to 20% is the monocrystalline, polycrystalline, multicrystalline photovoltaic. Between 25 to 45% in this range, okay, is what is available for wind energy turbine. Now, what about hydro? See hydro, between 75 to 95. So this means that it's have high efficiency power plants. Now, usually efficiency for hydro calculated as the electrical power delivered to the bus divided by potential energy of water. Okay. Now, definitely losses to be considered, losses on the turbine and the generator themselves. You know, at the end, the friction is there. Okay, similar to the situation of wind. Wind, there is a friction also because we call it windage sometimes. Okay, we call it drag aerodynamic, as we discussed before. These need to be calculated also and considered, but it's at the end small. For that, the efficiency is high. Now, the formula we use to generate the power of the hydro plant, okay, is gravity G 9.8 something, okay, we approximate it to 10. Efficiency of the system, head and water flow. We multiply them, we come up with the power generated. Let's take this formula in this example. Have a look. He told me consider a mountain stream with an effective head of 25 meters. This is the head. And flow rate Q, water flow rate, is 600 liters per minute. Okay. How much power could a hydro plant generate? He gave you, assume the efficiency to be 83%. Now, head is given flow rate Q is given in liter per minute. I need to convert it into cubic meter per second because we work on IS unit. So 1 cubic meter over 1,000 liter multiplied by 1 minute of 60 seconds. We got it here. Efficiency given, let's substitute. I have efficiency, I have Q, I have H. 2.1 kilowatt is what this small, let me say, hydro system produce. Now let's convert it into energy. I multiply by time. By the way, for hydro, one of the good issues here, or the advantages, it's work 24 hours, 7 days a week. Not similar to, let me say, the solar. It's work on day and not working at night. Wind, when it is windy, when it is calm, it's not working. No, this is working 24 hours, 7 day a week. Now I will multiply by 24 hours per day, 365 days per year. It gives me this amount in kilowatt hour annually. So if we assume, let's assume, he told me that, the question, that every person utilize 3,000 kilowatt hour annually. So I will divide this number by 3,000. It gives me 6.13. Let me say 6. It means only 6 people will use the energy for this system. This is small system. Let's take another example. The same example, but improve it. Let's say we have 100 meter height. Okay, the height now is 100. And the flow rate is 6,000 cubic meter per second. This is the same information for Niagara Falls, okay, between Canada and United States. Now let's substitute the same efficiency. I took the same efficiency Q, I have it, H, I have it. 4.98 gigawatt is the power production. Now if I multiply this by 24 hours, 365 days, 43.6 terawatt hour is the energy. If I divide by 3,000, it gives me 1.45 million people use it. This is waterfall. It's there by nature. Okay, we will not affect it. It's still there. Will not depleted. Will not affect the tourism. Will not affect. We will not do anything. Just water. Use it to generate electricity directly. Waterfall from height. You got it? So it's really huge. It's really huge to utilize this energy. I think I will stop with this point for hydro. I discussed the hydropower, the pressure of hydro, how we use it to generate electricity. Next session, we will talk, inshallah, about other sources coming from water. We will talk about tide, wave, otic, ocean thermal energy converter. The 3 technology utilize the energy in water, but in different way. Okay, in different way. Some of them they use pressure, some of them they use heat. Okay, but at the end it's coming from water. We call them ocean. Sometimes they call them ocean energy. So